Dear viewers, welcome to another video in the series of TRIS Inventive Way of Problem Solving. In our previous videos in this playlist, we have explained about what exactly is called a TRIS Inventive Way of Problem Solving, what is called a physical contradiction, what is called a technical contradiction, and in case of technical contradiction, how you can use TRIS contradiction matrix to try and find a known solution for a common problem. So these are things that we have already covered in the previous modules. In today's module, we will understand about what is called the separation principles in TRIS and how separation principle will help you to solve physical contradictions. Let's get into the video. As I was explaining in the introduction, this video is to understand what is called separation principles and how separation principles as a concept in TRIS will help us to move one step forward in solving physical contradictions. To start with, what is called a separation principle? TRIS separation principles are basically four standard ways of resolving physical contradiction. A situation where a same object or a system must have two opposite properties. Let's assume a part supposed to have a characteristic called A. Also, as another requirement, the same part is not supposed to have that characteristic A. If I want to make it easy and simple for you, if there is a wound in my skin and I want to use a band-aid, right? The band-aid should stick to my skin. At the same time, the band-aid should not stick to the wound. That's a requirement. Similarly, when we are talking about metal being used, the metal need to be soft at the time of giving a shape to it, forming or giving a shape to it, but the same metal should become hard when it is finally being in use as a finished goods or a product. So these are all what we call it as physical contradictions. Now these physical contradictions need to be handled using four standard separation principles. Let's understand what are those four standard separation principles. The first standard separation principle is separation in time. And what do we mean by separation in time? Let the object have property A at one time and not to have that same property A at another time. And this is what we call it as separation principle. As I was talking before, the metal must be soft at the time of shaping or forming, but need to be hard when it is in the final use as a finished goods or a product. So the hardness and softness are physical contradictions, and it need to be present at two different stages of our requirement or process. The second separation principle is separation in space. As I was explaining in my example, separation in space is nothing but giving different properties in different places. Property A in one region and property A should not be there in another region. For example, the front or the mating part of the tool must be rigid so that it is able to transmit force into another metal. If you are using a grinding wheel or a cutting tool, right? So these are all tools where the edge or the front end which touches the other metal, that part has to be rigid to transmit the force, whereas the place where you hold the tool, that part has to be soft to give you a comfortable grip. So this is what we call it as separation in space. Or another example which we can easily understand, real life example, is a band-aid that we put on a wound in our skin should have stickiness on the area where it is going to touch the skin and should not have stickiness on the area where it will touch the wound. So that is what we mean by separation in space. The third separation principle is separation by condition. And what we mean by separation by condition? Separation by condition is nothing but make the property dependent on an external or internal condition. If you are under condition C, then give A. And if the condition C does not exist, don't give A. So if I want to give you an example for this, the camera sensor, for example, if you are using a camera, the camera sensor have to be highly sensitive when you are trying to take a picture where the light or the luminosity is very low. Whereas if you are in a bright spot, the sensitiveness of the camera needs to be relatively adjusted so the image does not look extremely saturated. So the sensitiveness of the camera is a property, and that property should operate at a different level or at a opposite level, provided the amount of luminosity in the place where you are trying to take a photograph. And this is called separation by condition. Here the condition is how much light is there where you are trying to take a photograph. And the fourth separation principle is separation between parts and whole. And what we mean by that, assigning conflicting properties to different elements of one particular part. For example, I need a window which is transparent so that I can see through the window. At the same time, the window should be able to resist the impact. For example, if somebody is playing a sport outside your home, let's assume they play cricket, the ball strikes your window, the window should have the ability to impact or resist the impact. So it should be strong. At the same time, it should be transparent, and these are two opposite requirements. How do we achieve it? We can achieve it using a method called separation by parts. That means bring two parts to the window as a whole. We can break it into two parts, and one part of that will take care of the window being transparent to see through, and the other part will take care of the window being strong to resist the impact. So these are the four separation principles that we see in TRIS, inventive problem solving methodology to handle physical contradiction. Now let's go in detail and understand, because I would like to quickly summarize. I don't want people to have a misconception about what is called a technical contradiction and what is called a physical contradiction, and how you can use separation principles to solve physical contradiction. These are different, but they are related to each other. So that's why I would like to quickly summarize what you have already seen in my previous modules. I would like to summarize in this slide. A technical contradiction is a trade-off between two parameters. A technical contradiction occurs when improving one characteristic of a system causes another characteristic to worsen, and we have seen a lot of examples for that in the previous video also. But in this video also, I would like to give you some example. If you are trying to make your aeroplane stronger, it will automatically becomes heavier. Being strong and being heavier are technical contradictions, right? And if you try to design an engine to go fast, the vehicle to move fast, it automatically consumes more fuel, so it is less fuel efficient. So this is a technical contradiction, right? To make a product more reliable, maybe we need to have the child parts or the raw material being used at a superior quality. As a result, it becomes more expensive. Technical contradiction, right? So these are technical contradictions, and in the previous video itself we have seen how do we solve a technical contradiction. We solve a technical contradiction by using a TRIS contradiction matrix. So here you will find 39 technical parameters on the horizontal axis, as well as the same 39 technical parameters on the vertical axis. And if you want to achieve one of these technical characteristics, not compromising the other. So for example, if I want to give you an example, weight of a stationary object need to be controlled, but the length of the stationary object should not get impacted. In order to achieve or to reduce, keep the weight low, I should not have an impact on the length of the stationary object. Then the matrix says you can go for the 40 TRIS inventive principles. You can go for principle number 10, 1, 29 and 35. So I can go to the list. I can see what is 10. 10 is prayer action, 1 is segmentation, 29 is pneumatics and hydraulics, and 35 is parameters change. So these are all the inventive principles. I can go to each of these inventive principles, dig deep, and then try to get into a brainstorming session based on these inventive principles. This is how we handle technical contradictions. What is a physical contradiction? A physical contradiction is an opposite requirement of the same parameter. And what do we mean by that? A physical contradiction exists when the same system element must possess two mutually exclusive properties. Again, examples as we told, a car body must be light enough to achieve good speed. At the same time, it should be heavy enough for a safety related concern. If there is a crash or an impact, if there is a collision, it need to be strong enough. So these are two opposite requirements, right? A drill bit must be hard for it to cut or drill the metal, but it should also not be brittle to avoid getting broken, right? A coffee cup must be hot enough to retain the temperature. At the same time, it should not be too hot or cold enough to hold it comfortably. So these are all the different physical contradictions. Once we frame this physical contradictions, from here on we can move to something called separation principles. And what are these separation principles? As I told in the introduction or the beginning of this video, separation principles are some predefined separation principles of TRIZ which help us to handle these physical contradictions in a better way. So there are four separation principles: separation principle by time, separation principle by space, by condition, and by parts and whole. We have seen definition of each of this in the previous slide. Now let's get in deep in each of these and we will understand how to handle each separation principle. Separation principle, which is separation in time. So what is separation in time? Separation in time as an idea calls for having a property called A at one time, and the same A should not be available at another time. This is what we call it, the idea of separation in time. And when do we use it? When the conflicting properties are required at different time, right? The same product might require a particular characteristic but at two different levels or but at an opposite level. And implementation techniques, sequencing, cycles or change modes, time dependent treatments. So these are all the techniques by which we will get this one implemented. And generally, how does the contradiction looks like? I have given you an example contradiction here. The metal must be soft to shape or form, but then the metal should also become hard in order to use it as a final product. And this is what we mean by separation in time. So if I want to go a little bit deep and give you a contradiction, this is how the separation principle need to be worked. Physical contradiction: the metal must be soft to shape and form but hard in final use. And separation in time solution will look like: during manufacturing, the metal is kept soft so it can be formed. Basically, you will heat the metal and you will make the metal soft so that it can be formed or it can attain a required shape. And after forming, it is hardened by techniques like tempering or quenching so that the two opposite states exist at the two different times, right? This is what we call by separation in time. The next technique is separation in space. And what do we mean by separation in space? As an idea, separation in space is give different properties in different places. The characteristic A or property A should be available in one region and should not be available in another region. And when do we use it? When you can physically partition the object or create different zones. The same product at two different zones need to operate in two different ways so that the characteristic operates at a two different level or at a opposite level. And when we do it, we can do it, or what is the implementation technique? The implementation technique is partitioning, creating barriers, layered structures or localized functions. So these are all the implementation techniques. And if I want to give you a sample contradiction, the tool front must be rigid to transmit force, but the user need to have a soft and comfortable grip. So as a physical contradiction, the tool's front end should be rigid and the place where we hold the tool should be soft to give you a firm grip. And in separation in space principle, the solution will be rigid internal structure to transmit force with a soft outer sleeves for a soft grip area. So this is how we will think about a separation in space kind of a solution. The third separation technique is separation by condition. And what do we mean by separation by condition as an idea? Make the property operate dependent on an external or internal condition. When to use it? When you can change the system state or trigger a transition with a measurable parameter. If there is certain amount of vibration, operate like this. If the vibration level is less, operate like this. If there is certain amount of temperature, operate like this. If the temperature level reduces, operate like this. This is what we mean by ability to change the system or trigger a transition by a measurable parameter. Here temperature, pressure, light, all these are your measurable parameters. And what is the implementation in technique? Implementation technique is to come up with parts or come up with solutions or systems which have responsive materials. As part of your assembly, think about having sensors, actuators, or you know systems which behave based on certain level of measurable parameters. And to give you a sample contradiction, a camera sensor want to be very sensitive in low light areas but not so sensitive at a bright light area, so that your image does not get too much saturated. So as I was saying, the physical contradiction is to have a camera sensor where it is more sensitive in low light area and less sensitive in a bright light area. And how do we achieve this? We can achieve this by having a sensor that changes the gain and exposure depending upon the light level. You need to have a sensor to measure the available luminosity in the area, and based on that, the camera should have a system to dynamically change its gain and exposure. That's how you handle separation by condition. And finally, the fourth technique is separation by parts and whole. And what do we mean by separation by parts and whole? As an idea, assign the conflicting properties to different elements. And what do we mean by that? We don't make a solution as one single unit, but we separate that one single unit into smaller elements, so that each element will be in a position to achieve the expected results. And if you combine them together, the whole unit will also be able to achieve the outcome. And that is what we mean by separation by parts and whole. And where do you use it? When you have techniques or implementation techniques like modularization, composite materials, hybrid designs, combining subsystems to work as one unified system. These are all places where you can implement this technique. And if I want to give you a sample contradiction, a window must be transparent and impact resistant. So I want a window which is transparent to see through. At the same time, the window should also be impact resistant. So this is the physical contradiction. And the separation between parts and whole solution for this is to have a laminated layer, the glass plus polymer. Individually, the glass provides the transparency that we are looking for, and the polymer that we are going to have will try and give you the energy to resist impact or provide energy to absorption, right? So this is how the four techniques work. I have given only a simple examples here. In our following modules, I am planning to give you detailed examples, some case studies on how to handle each one of this. Once we have an in-depth understanding of these four techniques, the next thing that we need to know is how to apply this separation principle. There is a step-by-step way to do this. And the first step here is to identify the physical contradiction. So we need to understand the scenario in front of us, and we need to clearly come up with a physical contradiction statement. And that physical contradiction statement will look like, you need to have characteristic A, but you should also not have this characteristic A. And when to have it, when not to have it, can be decided based on time, can be decided based on a particular condition, can be decided based on a particular position, or both should be coexisting. Both the scenarios should be coexisting. So writing that physical contradiction is the first requirement. And once we know the physical contradiction, then we need to choose the separation principle. We have already seen the four separation principles: separation by time, separation by space, separation by condition, and separation by parts and whole. So once you know what is your separation principle, then there is a standard separation principle versus 40 TRIS inventive solutions matrix available. So we can use this invention, that is inventive principles, the 40 TRIS inventive principles matrix, which are designed to handle each of these separation techniques. So I have this matrix as an Excel format. I would like to show you that Excel format here. Just a minute. So this is the separation principles versus 40 TRIS inventive solution matrix. For example, if you are looking for separation in time, so I'm doing a filter here, separation in time, then these are all the possible inventive solutions that already exist, from which we can start our brainstorming to find out solution. Or if you are looking for separation in space, then you can put a filter here and identify these as your principles from the list of 40 inventive principles. Similarly, you can do a filter on separation by condition and look for the principles which can be used under this scenario. And the last one would be to have separations by systems and parts, right? Systems and whole, or parts and whole. And for that, we can have these 40 inventive principles. So people who are interested to have a copy of this Excel file for you to implement TRIS in a easier way in your work area, feel free to write to us. I will share the email address. You can write to our email address. We are more than happy to share this Excel file with you. And once you use this Excel file and identify the solution, then you need to start doing the brainstorming based on the solution that we have identified. From that point, the brainstorming will be more focused. And once you brainstorm and come up with solutions, you can prototype some of those best fitting solutions and then see if you can go ahead and implement it after the testing. So friends, I hope this video was helpful for you to understand what exactly this concept of separation principle is and how separation principle should be followed once you establish your physical contradiction. What are the 4 types of separation principles, like separation in time, separation in condition, separation in space, and separation as a part and as a whole. And once you have these 4 figured out, then use your separation principles matrix to find out which of the 40 inventive principles will best suit for your given situation. And once you know those 40 inventive principles and you have shortlisted a few of them, you can use that as a starting point to do brainstorming. As a result of your brainstorming, you can come up with different solutions. Then you can use techniques like puff matrix, or there are few other techniques available from which you can shortlist few of those some techniques that you are some ideas that have come in your brainstorming session, and finally you can implement it as a prototype and see if the test results are satisfactory and go for a full scale implementation. Thanks for your time. We are planning to come up with one example case study or scenario based video as our next video, where we will start with a practical problem statement. From that practical problem statement, we will try to frame a technical contradiction. Followed by that, we will frame a physical contradiction. Then I will show you an example of how the technical contradiction can be resolved by using a contradiction matrix. And similarly, the physical contradiction can be categorized as one of the separation principles. And finally, we will use those separation principles and then use the separation principles matrix to find out again the standard 40 inventive principles from which we will identify few which will best to suit the scenario. So our next video will be a example video where we will be discussing a practical problem and how the technical contradiction, physical contradiction, separation principles and contradiction matrix, separation principle matrix and 40 TRIS inventive principles can be used together. So please subscribe our channel to get notified as and when we upload videos on TRIS inventive problem solving. Thank you for your time. See you in another video.